702.
The Naked Scientist.
So Chris Smith, the Naked Scientist, is with me. He's been telling my technical producer, please remind Aubrey, it's not Naked Science, it's the Naked Scientist. And please give us a call on 011-883-0702 with any questions that you might have on the science front. And Chris will be here to answer any of those questions. Chris, thank you very much for joining us. I appreciate your time.
Aubrey, it's a pleasure. Good to talk to you again. It's been a little while, actually, hasn't it? Since we last had a chat.
It has been a while, Chris. It has been a while. Thank you so much. I'm going straight to the lines. Andrew is in Hammanskraal. Hi, Andrew.
Hello, Audrey.
Yeah, hi, man. What is your question for the Naked Scientist?
Okay, yes, I do have a question. Hello, Dr. Chris. In the 70s, NASA sent Pioneers 10 and 11 into interstellar space as trailblazers, and they later sent Voyagers 1 and 2. I just want to know if NASA is still in contact with all of them.
The Voyagers are still going. Amazing feat of engineering in some respects. They have now left the solar system. They've gone beyond the heliopause, which is the boundary where the pressure, the radiation pressure of our sun meets the radiation in intergalactic space. And so they're out there within the galaxy, and they've actually effectively left. Signals that we send to them take more than a day to get to them. They're so far away, and so those signals take more than a day to come back. They're powered by a thermoelectric generator. They've got a radioactive piece of, I think it's plutonium in them, might be polonium, but it's very, very hot, and this produces the heat that then is turned into electricity in those probes, and they are still running. Not all the systems, they've had to shut down some of them, but many of the systems are running, so that's how they're still able to communicate with them. I don't know about the other probes you mentioned, but certainly the Voyagers are still out there, and as far as we know, they'll carry on at least until the end of our galaxy or our universe.
Wow.
They're never going to disappear. It'll be a long time before they get anywhere else, though, as in tens of thousands of years, I think, if not more, before they reach anywhere else meaningfully. But they're carrying on out into space.
Dimitri is on the line. Hi, Dimitri.
Hi, thanks very much for the show.
Yeah.
I wanted to know if you've got any views about 5G technology and the human health aspects. There's a lot of conflicting stories going about. Some of it's labeled fake news. Have you done any research or perhaps know about 5G and potential health hazards?
Hello, Dimitri. The mobile network next generation of communications is this so-called 5G. The G stands for generation. And this is the next increment. And it uses a higher frequency, shorter wavelength radiation, which can pack more data in. Because if you think about how these things work, they're using microwaves to send information. And by adjusting the shape of those microwaves a bit, you can add information to them. So the more microwaves that there are, in other words, the shorter the wavelength, the more you're packing into a certain set of wave cycles, the more information you can convey more quickly. And so 5G is a step up because you are able to transmit much more data. The downside is that it doesn't travel so far. So what you have to do is you have to put out more power, and you have to make the cells that they're in a lot smaller. And the idea is then you're talking to fewer devices within each cell, and you can also make them a bit more directional. Now, obviously, people are justifiably concerned that there may be a health impact of this, because obviously you're providing the base stations that both send and receive this data in a very dense network all over places where people are. And therefore, this information, this stream of radiation, it's microwave radiation, will be hitting us. But there's no evidence that this does us harm, because the regime of radiation that's being used is not ionizing radiation. And what ionizing radiation means is radiation of sufficient energy or power to break the bonds between atoms or knock electrons off of atoms. Microwaves can't do that. They merely shake molecules around, and by shaking molecules, you make them hot in the same way that you get warm when you rub your hands together. So as far as we know, and it's early days, but as far as we know, there is no evidence that these sorts of wavelengths can do you any harm, which is why governments are comfortable at the moment to be using them. But this is a learning experience, and we're doing a huge natural experiment across the whole planet because people are using these sorts of devices and being exposed to these sorts of radiations all the time. And therefore, if there is some kind of evidence of harm, we will see it reflected in people's health. And the reassuring thing is that over many years of using similar regimes of radiation, we haven't seen any kind of association with a health impact. So for now, people are comfortable that this is not going to harm our health. And in fact, it will be beneficial because it will enable us to have faster rates of data transmission, be more connected, and have a better user experience on our devices and enrich our lives in various ways. But people are certainly watching carefully, and if there's any sign that there is danger afoot, then hopefully they would immediately admit to that, and they would therefore scale these things back. But at the moment, there's no evidence that's the case.
Joe is in Killarney. Hi, Joe.
Hello, Aubrey. How are you?
I'm well, thanks, Joe. Go ahead.
Good. Dr. Smith, I'd like to ask you a question with regard to the coronavirus, COVID-19. Two questions. One, is there any possibility that it persists and becomes a chronic disease? And secondly, would you like to speculate that despite the herd immunity we will acquire, that the coronavirus will transform very much like the flu virus, and that every year there'll be a different coronavirus?
Hi, Joe. Okay, so the first question is the risk of a chronic infection. Now, there's two ways of thinking about that question, whether you mean chronic as in it will continue to circulate around the world, infecting people year after year after year. We think that is going to be the case. We think this is going to become an endemic infection, endemic to the human race, and continue to transmit all around the world, probably producing in the vast majority of people symptoms of the common cold. The other way of asking the question, is this going to become a chronic infection, is chronic for the individual. Chronic meaning long term, producing an infection that doesn't go away and persists in that individual almost indefinitely, or at least for a very long time. Certain viruses do this, things like hepatitis B and hepatitis C, both viral infections that attack the liver, can do this. There are some rare examples of COVID doing this to people, but the people that it does this to are usually people who have a problem with their immune system, either because they've had cancer and had cancer treatment, which has damaged their immune system, or they've had a problem with their bone marrow or their immune system itself, and that means they can't fight off the infection. So it's poorly controlled in the body and it keeps on grumbling and the infection can't be removed. Those cases do exist. In fact, I've had some patients in our hospital with this problem, but they're very rare. The vast majority of people get an acute infection, their immune system responds meaningfully, and it spits out, kicks off the virus. The last part of your question is what happens in the long term in terms of if this could become like the flu and have a mutation rate that means we have to continuously update vaccines and things. This seems less likely, and the reason it's less likely is that the flu mutates and changes more rapidly than this new coronavirus. The new coronavirus mutates only very slowly and in such a way that it doesn't demonstrably change the behaviour of the virus or its appearance to the immune system, at least for the moment. And therefore we have confidence that we won't have to update vaccines that fight it off, but what we don't know is how long those vaccines will give you immunity for. So we may still have to keep updating your vaccination, but not because the virus has changed, but because your immune response has changed and dwindled with time. And that happens with a range of viruses, including other similar coronaviruses.
All right. Trish is in Braamfontein. Hi, Trish.
Yes?
Yeah, go ahead, Trish. The Naked Scientist is listening.
Hi, Trish.
Oh, thank you. My question is, why is Neptune and Uranus cold, but Mars is a little bit warm?
Ah, okay.
Okay, Trish is 9 years old. Chris?
Well done, Trish. Good question. Right, they're very different things. Mars is a rocky planet, and it's our next nearest planetary neighbour. It is the fourth planet from the Sun, and it's quite close in the grand scheme of things between where the Sun is and where Mars is. So quite a lot of sunlight gets to Mars and can keep the surface of Mars a bit warmer. The surface of Mars, it's still pretty chilly. On a warm day on Mars, it's about naught. So it's still very, very cold, but not anything like as cold as Neptune and Uranus. And if you look at where they are, they're much further out because you've got to go beyond the asteroid belt, then get to Jupiter, and then get to Saturn, and then beyond there, you get to Uranus and then Neptune. And they're a really long way out from the sun, which means that the amount of sunlight that's reaching them is much weaker. So it's much cooler. They're also very different planets. They're what are called gas giants. So they're absolutely huge, and they are made of a big shroud of gas, mostly hydrogen, which is squeezed down, and there probably is a little bit of rock in the middle of the planet, but most of it is very dense hydrogen gas, and it's very, very cold there. And this is partly because the fact that they don't have any volcanism, they don't have any of their own heat coming from within the planet to warm them on the scale that because they're so big and they're a very long way from the sun.
Well, Trish, thank you very much for a great question. Chris, I'm going to take a quick break. We'll be taking some more of your calls on 011-883-0702. Whatever questions you may have for the Naked Scientist, he's here to take any of those questions on 011-883-0702 when I come back.
At Liberty, we're in it with you. Just like you, we've had to adjust to this brave new world where the meetings are virtual and the challenges are real. It hasn't been easy, but our financial advisors are ready to help you make sense of what's happening. To be your personal guide, to stand by your side and fight for your financial freedom, because they're in it with you. We can't predict the future, but together we can plan for it. Call 0860 327 327 and let's chat. Liberty, in it with you. Liberty Group is a licensed insurer and an authorized FSP. T's and C's, risks and limitations apply.
Courage is beautiful. The way it shines from the heart of our healthcare workers, the way they put themselves on the front line, the way they're fighting for our safety. And we're saying thank you. Dove is donating to ICAS to care for the mental health of our frontline healthcare workers. So now they have a 24-hour toll-free helpline for them and for their families. Dove Care on Call, 0800 111 019.
Luxury Lifestyle Living has a new address at the Leonardo All-Suite Hotel and Residence in Sandton, where guests can work, live, and play. The Leonardo boasts 240 residences, 9 state-of-the-art all-purpose conferencing venues and meeting rooms, a world-class gym, Leonardo Spa and Preschool. The Leonardo also has a variety of eatery options, including Leo's Lounge with premium coffee, GIY, and wine menus. There's also Octobar, which serves wood-fried pizzas, tapas, snacks, and the finest spirits, wine, and signature cocktails. To book your Leonardo stay, visit theleonardo.co.za.
702.
You can call us
on 011-883-0702.
Dr. Chris, the Naked Scientist, is here with us, and he's taking your calls on 011-883-0702 on any questions you might have of a scientific nature, of course, and he'll do everything he can to answer that question. Let me quickly read you this question, Dr. Chris. This person is, hi, Dr. Chris, please tell me what causes the ringing in one's ears and how can one stop it? And that's from Lee.
Hi, Lee. Well, the answer is that ringing in your ears is a condition which is called tinnitus. And this is very common. More than 20 to 30% of people, as they get older, experience this symptom. In some cases, it's temporary. In many cases, it becomes a permanent or chronic thing. It's usually associated with you having in your past been exposed to very loud sounds, although it can be caused temporarily by things like infections or exposure to certain drugs. Things like aspirin at very high doses, which are used therapeutically sometimes, can produce a temporary ringing in your ears. The reason it happens is if you've been exposed to very loud sounds, those loud sounds damage the inner ear, which is a structure called the cochlea. And the cochlea is the structure that converts sound waves or vibrations in the air into nerve signals or brain waves, if you like, that the brain can understand and interpret as sounds. And different parts of the cochlea decode sounds of different frequencies. So if you're exposed to really loud sounds of a certain frequency for a prolonged period of time, the part of the cochlea that normally does that job of converting the sound vibrations into nerve signals is damaged. And in the absence of input to the brain from that part of the cochlea, the brain turns up the amplification internally because it's unable to hear any signals coming from that part of the cochlea. So it assumes that it's not listening hard enough. And it's a bit like if you're tuned into a radio station and you can't quite hear it and you turn up the volume, the interference gets louder too. And those whistling noises that are tinnitus are the interference. It's neurological noise generated by the brain circuits that are trying to make sense of the absence of sound or a weaker signal coming from that part of the cochlea. So what are the treatments? Well, the treatments are, if it's caused by drugs that you're having to take temporarily, then you reduce the dose of the drugs. Not everyone's that lucky. If it's caused by sounds, try to reduce your exposure to loud sounds. Wear ear defenders. Don't go to too many loud parties. Don't play your music too loud. If you're wearing headphones, keep the volume in your headphones down a bit. If it's something that's now become a problem for you and it doesn't go away, then A, get it checked, because it might not be just down to the fact that you've had exposure to loud sounds. Other things can sometimes cause this. Problems inside the head can sometimes do this, and you might need some medical help. So get it checked to make sure the diagnosis is correct. And distraction treatment is very, very useful. And what that means is that sometimes exposure to low-level noise, not silence, but low-level sound, can help to mask the whistling sounds or whatever your tinnitus sounds are, and take your mind off them. Because if you focus on them, the hearing system is very good at tuning into and amplifying things that you're concentrating on. So the more you focus on them, the worse it's going to get. So try and distract yourself from not focusing on it, and you'll find that it becomes less intrusive for you.
On the WhatsApp line, Angela asks, please ask Chris, why do we dream when we sleep? Why is it that dreams seem to be of the same treat? For example, scary dreams all the time. Why do some dreams reoccur? And that's from Angela.
Well, first of all, why do we dream? Well, we don't know why we dream, but we're not alone, because if you look at other animals, our pet dogs and pet cats, they dream as well. And we know this both by looking at them. You can tell when they're dreaming because they may have small movements, they may make sounds, they may vocalize or woof or meow in their sleep. And humans do exactly the same thing. And if you measure the brain waves of individuals that are dreaming, you can see the same patterns of brainwave changes in animals and also in humans that correspond to dreams. When we go to sleep, sleep isn't just a static thing where your brain turns off, you lose consciousness, and then 8 hours later, hopefully, you wake up and you're back to normal. Sleep is a very dynamic thing, and as you go through the night, your brain changes its level of activity. Sometimes it shows very low levels of activity, and then periodically there are surges of brain activity, big bursts to brain activity levels almost equivalent to when you're awake. And if you look at a person when they're in that state of brain wakefulness, their eyes are moving around a lot. And this is called rapid eye movement sleep. And that's the time when, if you wake someone up during that phase of sleep, they'll very often report that they were dreaming. And as you go through the night, the periods of REM sleep become longer. So the dreams you tend to have tend to become richer and often more emotional or more powerful experiences. And you're also more likely to remember them because you're more likely to wake up towards the end of your night of sleep when you're therefore having one of these longer phases of sleep, of dreaming. And then you may or may not remember what you've been dreaming about. We don't know why this happens. We don't know what the purpose of dreaming is. We think it's because different parts of the brain are processing information, because we know that memory becomes much more consolidated, or things make a lot more sense once you've had a chance to go to sleep and to dream about them. And it may well be it's got some kind of role in helping the brain to clear out rubbish information and strengthen the associations to do with information that's meaningful. But we don't know for sure. All we know is if you don't go to sleep, you die, or you can become mentally unwell. Animals deprived of sleep will die. And if you don't have proper sleep punctuated by dream phases, you don't feel rested and you don't get the full psychological benefits of a night's sleep. So dreaming is very important, but we don't know why it happens. We don't know what its role is, but it does appear to be very important for sort of psychological well-being.
Jeff is in Woodmead. Hi, Jeff.
Just a quick one here. I was reading something the other day, and the question was posed, what is the size of a photon? And the answer was approximately the wavelength. Now, that doesn't make any sense at all, because if it's a microwave, then it's the size of a baseball. So what is there some kind of formula that determines that? Because my imagination would be that a photon is a very tiny quantum of light. Is that right?
Okay, Jeff, you've asked me an impossible question, not least because I'm not a photon expert, but also because no one actually knows. And even Einstein had to fudge things in order to explain this, because as Einstein showed, and this was what he actually got the Nobel Prize for. Everyone thinks Einstein got his Nobel Prize for his work on relativity, special relativity and general relativity, but he didn't. His Nobel Prize came from some work he did in 1905, which was the photoelectric effect. Because people had known at that point that light was a wave. We knew light was a wave because you could do various experiments that you could see results of those experiments that were consistent with light being a wave, because it was behaving exactly the same way as if you made water waves. So people said, well, it's obvious light is a wave. And lots of the observations we make about light do indeed fit with the fact that light is a wave. But then Einstein said, well, if that's true, how do we explain the photoelectric effect? And the photoelectric effect is where light shines on a surface and effectively gives a kick to that surface, making that surface, whatever that's made of a certain material, spit out some electricity. And different colours of light have different energies. So blue light is much more energetic than red light. And the only way that you can explain that, because they're both waves after all, is if you consider actually that the light also comes in packets or photons. And hence, we tend to view light sometimes as it is a wave, and other times we have to describe light as a packet, a photon, which is a packet of energy. And obviously, you've quite rightly said, well, a microwave, the wavelength of a microwave, for instance, the microwaves being made in my microwave oven in my kitchen, the wavelength of those is 6 to 12 centimeters, depending upon what you're doing. I think it's about 12 centimeters. That's huge, but that's not one photon. So the photon is distributed right the way through that wave. So the two things are quite different, and we have to use two different definitions according to the situation that we're trying to describe. And that's why light is weird. And I can't actually answer your question in any more detail than that.
AR is in Malanshof, and he's 10 years old. Has two questions for you, Dr. Chris.
Go for it.
Go ahead, AR.
Okay, thank you. For my first question, I would like to ask, why is it that I can actually taste food in my sleep?
Why do you taste food in your sleep, Dr. Chris?
Yes.
Well, when you go to sleep, different parts of your brain become active again. And because the brain does different jobs with different parts of itself, there are parts of the brain that are concerned with seeing. There are parts of the brain that are concerned with hearing. There are parts of the brain concerned with speaking. There are also parts of the brain concerned with feeling, touching, sensing, and also tasting and smelling. And so it may well be that when you go to sleep and you dream about food, you can taste that because your memory of that particular taste or flavour is being summoned up by the part of the brain that stores that information becoming active in your sleep and presenting that to your sleeping consciousness. And so you summon up the memory and you encounter it in the same way that you can, when you go to sleep, dream about colours or hear sounds or dream up conversations or feel other sensations.
Dr. Chris, that's about all the time we have, and I want to thank you very much for the time you've given us. I'm looking forward to talking to you next time. Thank you very much for joining us.
It's a pleasure. Thanks, Aubrey, very much, and thanks everyone for your great questions.
Great stuff. Let's take a quick break. When we come back, we take news at 3 o'clock.